Okay, so we are live now, and good afternoon to the TT guy, Roger. And I'm most people who read the comments I write since 5 years know that my first name is Martin, and we agreed on that it does not dox ourselves too much if we use our first name to address each other. And the main reason to come here was about a year ago. I got the calculations by Roger, and there's also another YouTuber, the Sable Eagle, who also did a similar spreadsheet, how much, whether we can really expect to see the curve of the horizon or not. And the first thing we'll do here is that Roger shows us his way to calculate how much of the horizon could be expected to be seen. I will add 2 points to this a little bit later. One is about the human vision, the vision, the way we see things, which I think makes it impossible to really see with our eyes whether there's a curve, but we can do it on photographs, and we can compare it to something straight in our field of view, and it's actually very, very, very little. And I also did a spreadsheet with my own calculations, and the most part is completely the same as now Roger explains it. Only the last part, I will address it when Roger is through with its explanations. I think I have a little bit more generalized the calculations. But then Roger, start your presentation, and I switch to this view where we get your screen.
Thanks, Martin. Yep, I should correct you. It should be the maths. That should be plural because mathematics is plural, and
okay.
The Americans don't know how to pronounce the word maths. Anyway,
maths, not maths. Okay.
That's just a little dig at Americans. That's okay. I'm married to one. Many years ago, I was confused about how people figure out the maths of spheres, and so I decided to see if I could do it myself. I'm just a biologist, so I don't know much maths, but it turns out I don't think you need to know a great deal of maths. I think the most I needed was some trigonometry and how to solve a quadratic equation. And this is a video I just had on YouTube from I think it's 6 years old, so I look a lot younger.
So in order to do this, I've built myself a model of the Earth. Well, it's not much, didn't do much building really. It's a basketball, and it has a wire man sitting on it. So this bit here represents a person standing on the surface of this spherical Earth. So yeah, that's the line of sight to the horizon. So if he's looking down that bit of black wire there, that's the line of sight to the horizon. And I've got another line of sight to the horizon. Over this side, there's a line of sight to the horizon there. You can imagine the guy sitting there, standing on the Earth's surface, and if he looks off in that direction, he can see the horizon where his finger is. And then if he turns 90 degrees, he can look off to the horizon 90 degrees this way where this other finger is here. And if you look straight ahead, you know, he would expect to see the curve of the horizon going over like that. And the question is, how much of that curve can you see? How big is that curve at any given height? The shape of the little wire thing looks like this. It's kind of triangular, but it's got this arch, and this is it's the height of this arch that is the question. How high is that arch for a given height, observation height on the sphere? So yeah, figuring out the maths of that. And triangle with this side here. This is the distance to the horizon for a person who's, you know, that high. So, and I've just decided I'm going to assume that, you know, the person's looking out one way and then looking out the other direction 90 degrees, so their field of view is 90 degrees. In other words, this angle here is 90 degrees. So you've got a right angle triangle. With two sides that are the distance to the horizon. Now, we've got some maths that can calculate the different distance to the horizon, and therefore, because this is actually an isosceles triangle, and you know, if you know the distance on these two sides, you can tell the distance across the bottom there. And once you know the distance between those 2 points, and you know the shape of this circle, because this circle is the surface of the Earth, so you know the radius of this circle because you know the radius of the Earth, you can actually figure out how high that space there is using geometry, and that can tell you how high the arch, the dip, or the bulge should be. So we need to know the distance to the horizon, and you can figure that out using simple geometry and Pythagoras' theorem. So if you have a diagram like this, which has got a person that's h high standing on the surfaces of a, then you have geometry that is a right angle triangle and is about 5.1 kilometers away. Okay, so now we know the distance to the horizon is 5.1 kilometers, and so we need to figure out what the other distance is on this triangle, the distance across.
There's no sound anymore.
The bottom of the arch,
Okay.
and we can do that also by Pythagoras' theorem, and it the arch, the bulge, we know the figure out the geometry of the bulge. So now we look at the geometry of the arch, the bulge. So this is a diagram of that looking side on, and we've got the height of the bulge is unknown as h, and the base of the bulge, as we previously determined, is two lots of 3.57 or 3.6 kilometers wide. So that's marked on the diagram here, and then we've got the radius of the Earth. So we have a triangle there, a right angle triangle, with a side of 3.6 kilometers, another side of, which is the radius of the Earth, and another side radius of Earth minus h. And you can use Pythagoras' theorem to construct a relationship there, and it actually turns out to be a quadratic equation as shown here, which you can solve for h, the height of the bulge. So yeah, the height of the bulge is about 1 meter high at 3.6 kilometers distance, and so the question is, would you really be able to see that much, that small of a bulge at that distance? Well, the way to really answer that question is to figure out what the angle that sort of height would subtend to the eye, because that's the way you sort of determine the resolution of the eye, by measuring what sort of angle difference that sort of height would have at the eye, and you can do that again using geometry. We've got a 1 meter height difference at 3.6 kilometers away, and the question we're going to ask is, what is this angle here? This angle that it's this 1 meter height at 3.6 kilometers, what angle that subtends at the eye? So you can, this diagram is equivalent if you divide this triangle into two right angle triangles with an angle of alpha on 2 and a height of 0.5 meters. You can use trigonometry to figure out that 0.00014 radians, alpha on 2. So you figure out that alpha is actually 0.016 degrees. So the bulge would only subtend an angle of 0.016 degrees, and it's generally recognised that the eye's sort of resolution is actually 0.02 degrees. So this is less than the resolution that the eye can detect. And so yes, at a height of 2 meters, you cannot detect the bulge of the horizon.
Who is that young man there? Look at him. He looks so young. What do you think of that, Martin?
Yes, I think it was right to do it that slowly. Of course, people who watch something which is too fast can go back and forth, but I think it is perfect, and also the mechanical model you did is perfect. And just out of curiosity, you said something. You were a biologist or?
Yeah, I mean, I used to work as a plant geneticist, but now I work in IT. So I've had two careers in my life. Yeah.
But you are probably a little bit closer to the physiology of human vision than I am. And this would be the second point I'd like to address when it comes to the question, how much of the horizon can we expect to see? The first point I have is that I completely share your, how is it, maths?
Maths, yeah. Maths.
Completely share your maths, and I just have to fetch a piece of paper. Let me see where I have one.
Yeah, look, I mean, I know nothing about human vision. I just pulled a figure out of, off the Googles about what the resolution of the eye is. So
okay, we come to that. And where my approach was basically different, I can also show a spreadsheet later, but that is not that interesting, I think, and it's not quite finished. But what I wanted to show is, if we have a ball like this, I have acquired one here in Thailand at someone who sold these things at the beach.
Was it Dubai? Did Eric Dubay sell it to you?
No. Yeah, let me switch to a better screen layout for this.
You haven't
is
seen
he
Eric?
In Phuket? Is Dubai in Phuket? I don't think so.
I don't know.
Phuket World or Phuket is something. the fish and chips shop he has, I think, in Phuket old time, but I have no plans. Actually, I made it even a principle of mine not to communicate direct with any flat earther. I very seldom broke this, but now I have the following view of this thing. If we turn once around 360 degrees, we actually have a cone over. Yes, this is now a very, very high viewing position, but it's a little bit hard to make a shallower cone. But a person who stands up on Earth looks down to the horizon, and basically, if you add up all the lines of vision when he turns once around, you get a cone shape. I think we can agree on this.
Sure, yep.
That the horizon, I would have to cut this accordingly, but you would see. Can you agree on this?
Yeah, I do agree. Yep.
That it's basically a cone shape. Okay.
Yeah.
So my next point is, if we take a camera, because this is the only objective thing to compare things, what we can see, it depends on the angle of the camera. And if we leave out all lens distortion, something like this, and take the very basic geometry of pinhole camera, and any non-distorting lens camera is practically the same. Yeah, so we basically get a cross section of the cone, because the camera projects it to somewhere through a pinhole or something. And if we take the imaging sensor and put it, for example, vertical, it is a vertical section of the cone. If we look, if we put the horizon exactly in the middle of the camera, it would be that cut here. And for the relatively small heights, and we do practical observations, and even from an airplane flying high, it doesn't really matter that much if you have inclined the camera a little bit down or you don't. But if what some people want to see, if you are really far away, say on the moon, then of course people expect to see a full circle Earth. And that one you get, did you ever look into a cross section of cones in maths?
I don't
No?
think I have done that trick. No.
Okay, so basically many people may remember this from school. If you imagine you cut this shape and you do it this way, you get a circle. If you cut this cone that way, all around in a perpendicular to its vertical axis, if you cut it that way,
center your cone's off screen.
please.
Your cone is off screen. Yeah.
See. Okay, I do full screen. Thanks for reminding
Yeah, make me go away.
this. Yeah. Okay.
That's better.
So, okay. So now.
Yeah.
Okay. If you cut it perpendicular to its vertical here, you get a plane circle.
Yep.
Yeah. The cross section of this cone here. If we cut it that way. You see, if you cut it that way, this is a vertical vertical axis of the cone, looking down the horizon. Again, looking down to the horizon. Here, the horizon is something like around here. If you look vertically down, if you imagine we cut it here, in that way, or I do it in front of the camera. If we cut it here, then we get a plane circle. Okay. Yeah. And if we look a little bit from the side, we get an ellipse. And if maybe some remember it from school maths, if you are exactly parallel to this inclination here, if you do the cutting exactly, it's a little bit difficult to show. If you do it exactly parallel to this one, you get a parabola. And if you go even more inclined, which is a typical case when we look at very shallow cones, you get a hyperbola. And of course, I did not completely calculate these shapes, but based on this, I did my spreadsheet that I did based on different camera angles, differently looking down. And again, it is in the millimeter range, the difference that is different to your calculations. So right, yeah, especially if we just go up 100 or 200 meter, I think the top of the curve, we can go to my spreadsheet and look. The top of the curve, it changes marginally. And also, right, if we don't go up more than 200, 300 meter, we typically, if we have a camera, say that is the image is 2000 pixel wide, we get just 1 pixel of right, 1.5 pixel in the middle.
It sounds like your calculation is more mathematically correct than there's probably some.
Yeah, but it really doesn't make a difference to the way you did it. Yeah. For all practical observations, yeah, you can do with amateur means.
Yeah, I mean, I never thought to consider the angle of the camera pointing to the to a cone or
I was curious how much it will do, and my spreadsheet is not quite complete in this respect, because I'm a little bit of a perfectionist, and I at first had just compared if we view horizontal to the local horizontal, and if we view down to put the horizon exactly in the middle. And you know, this is less than a degree which we look down for practical viewing heights. So it hardly makes any difference. And the effect, if you have an ordinary camera with a flat image sensor, the effect gets a little bit greater if you view horizontal to a local horizontal as if compared to view directly down. But it doesn't really matter for practical viewing distances. But still, I want my spreadsheet to be perfect and to have the possibility to adjust the camera angle not only to these two positions, to horizontal and viewing down to the horizon, but I want to have any position so that I can also, for example, put 385,000 kilometer distance to the moon and view down, and then we should get, based on the distance to the Earth, and so then we should get the diameter of the Earth approximately, the difference. Because if we are very far away from Earth, we can simply calculate with Pythagoras how much curve we see. If we see the whole thing, whole thing from the moon, we can use Pythagoras. And that's what I want to do. And I can show you just for a minute the spreadsheet I made. I prepare it on the, before I share the window, I prepare it on the incognito window here. And I have it here on my Google Drive. So I cannot go there from the incognito window, so I have to use, yeah, okay. So I close this again and do it in an ordinary window. Just a second. This is the window. No, this is where I looked how to make someone moderator. Here I have it. And I pull out this window from the tabs so that it is a window of its own. And I make it a little bit larger. And I share it. It is just a second until I share it.
Shout out to Stories Denier in my chat. Hi, Stories Denier. And shout out to I Can Science That. Howdy, I Can Science That. Love your channel, man.
Okay, now I have to share this one back to the StreamYard window, and I press send, share screen, screen sharing with two monitors. Well,
hey, Stories Designer, invite Nathan Oakley into this stream, and we can talk to him. Yep, we'll chat to him in here.
I'm just fighting with a presenting mod, extra camera, slides, share screen.
Nathan Oakley, yay!
Share screen. Select tab to view, untitled spreadsheet. I think, yeah, this one is a chair. Okay, do I have to change something, or do you see my share screen?
I can see it, yep.
Okay, so we need not go to all the formula. I just explained a little bit what I did. All the values I have and the values I required, I listed up here down. I see I do it the same as you. I have usually I define in the spreadsheet pi for me as the arc of the inverse cosine, 2 times the inverse cosine of 0. Here is probably a little bit small to see it, 2 times a cos 0. This is from my C and C++ programming because there is no pi available as a constant. And
really?
From there I go, yeah, no, it isn't. It is the reason it is now in C++. It is the reason that there are three floating point formats, and you should use the floating point format for pi in which you do the calculations. Otherwise, you get deviation from the true value. And what I did here in this column, the right column, I used always the same units as meter and rad and so. And if I, for convenience, I want to input them in more convenient units, I put them in this and do the transfer to this column here. And all the complicated calculations I do based on this column. And so that I don't have to work with cell numbers, I have given all these names, all the cells names here, and I just, for me to remember,
fancy.
I put the cell names here, and they have an underscore km suffix and an underscore m suffix to differentiate between those two. And this is the thing that is not quite finished, where I can set either the camera to down angled, so the horizon is in the middle and not. And I have to perfect this. And here is the field of view. I can choose smaller or wider field of views. And okay, I won't go in this show through all the maths here, also because this spreadsheet is not quite finished. And just let me go back to the StreamYard page so that I can stop sharing. Here's the StreamYard page. Okay, so stop sharing, stop green screen share. Okay, here we are back. And the second part, which I would like to talk about, and I have often put this in comments, is if people write what they can see. And I cannot verify what someone else can see because I cannot connect to his visual nerves. And if you go to the physiology of the human eye and you look what resolution we have, you will see that in a very, very narrow degree, range in the middle, I think it's less than 5 degree field of view, the density of the rods and cones, our two kinds of light receptors, is much, much higher than to the outside. So we probably couldn't decide, even if we can discern in principle the height of the bulge in the middle, we don't have that precision if we go more to the side of the
sheet. I mean, yeah, and the number I come up with is best case scenario, probably. Absolute best case. Yeah.
And the next thing most people don't notice is they always turn either their eyes or their head to the point of most interest, where they have best view. And are you also astronomer, maybe, or not?
Oh, look,
I mean, sometimes in the night sky. Do you look sometimes in the night sky?
I have a shitty telescope, but yeah, I can see Jupiter.
Astronomers usually know the following: we have two kinds of light receptive cells in our eyes, the rods and the cones, and the one are much more light sensitive, but where we have the best field of the densest cells, they are also the less sensitive. So at the night sky, something is very typical. You look at the night sky and maybe 20, 30 degrees side off, you see something, you see a star, and you look at it and it goes away. And you look away and it comes back.
I've experienced that. Lots of people have experienced that, and it's it's a mind fuck. You go, what?
Yeah, and that is a reason, because once you look at it, you have I always forget, I think the rods are the more sensitive cell. If you look at it, there are no rods, they are light sensitive. And so you can notice that automatically you look at things, and if you do this with a horizon and turns 360 degrees, you can naturally see nothing curved, because if you go around everything, every point of the horizon has the same distance, so there's nothing you can see curved.
Yeah, I mean, my 90-degree field of view is a best case scenario as well. Yeah, I mean, So I mean,
And if you zoom in to see height differences better, you lose your field of view, and it gets more straight. So it is also with the camera, it is difficult to see.
You got to take a photo, man. You got to take a photo and do that horizontal compression thing. Then you can see it. See any curve?
Yes. For example, photo horizontal compression, you can see it, and other ways. But basically, our eyes are not precise optical measurements instruments, and there are so numerous optical illusions that shows how our brain takes other clues into consideration to decide whether something is straight. So you would have, if you can take a photograph, you would have to go very, very high and put something that is straight in front of your view, and then you may have a chance to see a slight curve.
Yep, like the good old Rory photo from up the top of the cliff. I don't know if you know what I'm talking about, but it's a photo from a cliff that a guy named Rory took. MC Tunes published it a lot, but and he's got a straight line, a straight rule, and then he compresses it horizontally. It's a great Great image.
That was the guy that on the Canary Seas and did house sitting on the Canary Islands.
I don't know the details to that degree, but yeah.
He had put together a device which were two rulers very close together with only a very small, and if you put this in front of your camera, you can really see it without visual compression. I have forgotten his name. He skipped out of this whole thing because it gets repetitious now. There are no new arguments any longer.
Yeah, he's proved his point, and no one will believe him. So he did his best to try and convince the crazies, but no.
Yeah.
They pretend not. They pretend not to understand. I think they just pretend not to understand. Yeah.
Okay. Yes,
anyway, sorry.
And Martin, I just switched to the comment section for a short moment. Okay.
Yeah.
Yes, and maybe I don't know if you got notices of my last videos I published. Maybe you know I now. I usually don't respond directly to flat earthers, but I often think about how I can come up with things everybody can do. And my newest child is this thing where you can prove the shape of the Earth without knowing R. And it's always the argument by Dr. No, you know who I mean, the child slapper.
Right, yes.
Yes, Dr. No is his initials. He always screams out, but you need to assume R.
Oh, yeah.
And my newest way, did you see this? No, probably not.
No, was it the one where you walk east and west?
Yes.
Oh, yeah, you know.
I presented it 2 weeks ago, and the only guest in this live stream was Sable Eagle. I did it very early for Thailand time, and for him in somewhere in Great Britain, I think he lives. Was very late, and I immediately after the stream I made it private because I had forgotten to change my display name in this stream. And then I republished the stream, and that was my real name in the stream. And I did overlays over it, and then I republished it about a week ago. But you usually don't get notified for it. And what I do in this newest one, maybe I can present it. Let's present my view alone. I can explain it. I have also this one to show that it works independently from the size of the ball, and I don't even assume a ball in it. I have just make two predictions, a prediction for a ball and a prediction for flat. And let's go on with this one. And what I would need agreement with the people for the globe predictions. I do other predictions for flat, which always come out off by 20, 30, 40%, or even if you do it in Australia, I think by 100% wrong, and where the globe predictions get very close. And the only thing I need to agree to is if you go fully round it, it doesn't matter if you go that way around or if you go that way around or that way. Once at the largest diameter around is always, with a few kilometers difference, it's always about the same. And that's the first point of agreement. The second point of agreement I need is that if you go only a quarter round, then it's a quarter of the whole. Or if you go only 100th round, it's 100th of the whole thing, once whole around. So these are 2 points that are very hard to deny for them. And what I then do is, for this one, this is better. I also have a second camera here, maybe, but it has the colors don't quite match. But I can show it.
You've got the Earth up the right way around. That's good.
Okay, thank you.
No, that was the right way before. Southern hemisphere is the primary. Should be the top. Southern hemisphere.
Southern hemisphere on the top now.
That's better. Thank you.
Okay, and now here it's not so quite visible, but the meridians always, as they always go fully around, you can say 1 degree is 60 nautical miles or 111 kilometer always, and hundredths of a degree is then 1.1 kilometer or something. So it is directly proportional if you go around a latitude or in a direct straight northeast direction. It's directly proportional to the difference in latitude. I always have to think about this. So, but if you view the parallels, you see they increase the further they go to you go to the equator. It's probably hard to see with this extra camera, but we know how this works on the globe. But the ratio in which they decrease is a cosine function. No, it's a sine function. They increase rather all the more slowly the more we come to the equator. The parallels don't grow that much. And now if you walk the same distance, basically on a line of longitude, on a meridian, and it's not exactly a parallel. If you would go a longer distance, it would be a so-called rump line. But if you do the experiment for 200, 300 meter long stretches, it doesn't matter. So you can take one northeast and one north-south and one east-west, and they must have a specific ratio depending on the latitude you are at. And I make the prediction for an AE map where the parallels grow more and more, or I switch back to the other camera, where the parallels grow proportionally more and more the further you go south, and make a prediction for the globe where they first grow with a sine function and then get smaller with a sine function again. And this spreadsheet, I think I make a separate stream on it because we have now half an hour and I don't want you waste too much of my time, of your time with me. I will present it in a separate stream, maybe tomorrow or so. And currently I have only done this one. I can share it. Let me see. No, I have first.
We need to identify our locations using GPS as part of this, don't we?
Yeah, I just prepare a screen to share. I want to pull out the tab in which this experiment is. Just a second. We are probably. This is probably this one. This is not the untitled. I have to open it. It's on my drive. FE experiment, and here it is the beautiful Earth shape tester, which I chose for the acronym BEST for best. It's the best way to test the shape of the Earth. And now let me pull out this tab. It's always there come notifications on the top of the screen, and I cannot get to the tab I want to pull out on a separate page. So now I have it, and now back to the page where I can select what I want to share. This is this one, and I want to present a video. A share screen. And we have this one beautiful Earth shape tester version 0.99. There's a how-to, but here is the experiment which I think this is shared, but I have at home I have more control screens to see what really goes out. Now, okay.
We can see it. Yep, we can see it.
Okay, and it's quite simple. You need to find an L-shaped street or maybe a large parking lot in your vicinity, and you put in the coordinates. You can measure them if you do the experiment live. You can measure them with a GPS receiver. This is the point the people who doubt that this experiment is valid may then come up with and say, but GPS lies to us. there are counter arguments, but just let's for a moment assume GPS is right. You put in the junction point of the L and the two endpoints of the north-south and the east-west stretch, and the prediction, the ratio of both is 0.99 measured. I did this one measure on Google Earth, and the prediction for flat, where one would have to be 1.4 at this and 0.9 this, and here we are for globe, we are within 0.3% of the predictions, and for flat we are off by 30% because it's very drastic here at the equator. And I then did this experiment. I have to go back to the real spreadsheet side. This one. I have on other tabs, I have this one paced out. And I only counted how many steps I made in each direction, because the experiment relies on you go the same distance north-south and east-west. But here at the new hotel where we are now, we changed hotels about every week here in Thailand in our vacancy, and we are away a total of 5 weeks because we had to skip 2 years to go to shorten the German winter and go to a warmer region. And so we are now again in the same area where I did the experiment, and I hope and think in this hotel we are now, you can get bicycles, and with a bicycle it's basically easy to measure same distance as you can count the revolutions of the front wheel, and I'm planning to do this once more.
You must ride slow.
Impression.
You must ride slowly then if you can count the.
You can just push it. You can just push it beside you. It is practically this experiment is a 250-meter long stretch, and you can just push it along. And I'll do it probably again early in the morning, at 5 o'clock or so in the morning, and there's no one on the street and no traffic there, and. Maybe I have to check. Maybe we get the bicycles only between 8 in the morning and 8 in the evening. But I find a way to do this.
And you also think just pacing it out is accurate enough as well. You reckon?
It's still closer to the globe than to flat by pacing it out.
Yeah.
Okay, so I stopped the screen sharing again. Just a second. Here I have this one. Stop present. No. How do I stop screen now? Now we are back. Okay. So for the moment, that is all I wanted to talk about. And as we planned this since long, I now feel a little bit, I have done the thing we agreed on to do since long. And we know each other a little bit better, and maybe
in summary, your method doing it with all this fancy maths gave the same answer as mine. Pretty close too.
It's the same as with Newtonian gravity and Einsteinian gravity. Newtonian and Einsteinian don't deviate from each other for small.
I'm Isaac Newton. And you're Albert Einstein. Okay, that's fine. I'll accept that.
What I really like to do is to have an expert on human vision on the channel who maybe corrects me in my analysis that we would have no chance to see it with our eyes anyway.
Who cares? I mean, if you've got the best case scenario and you can't see it there with the absolute best case scenario, then there's no question. Who cares what the exact number is? And then you can, if you can use a photograph to actually determine it, because hey, human beings have invented instruments that work better than their eyes, despite what flat earthers say. So
When I read the comments of these top left on the Dunning-Kruger curve people, I regularly wish we could put them all together on a faraway island and let them live with all the inventions only they can make with the knowledge they claim they have, and we will probably never hear of them again.
Anything they've confirmed them for themselves. That's right. Yeah, that they've confirmed their quantum mechanics and for their iPhones or what have you. Yes. Yeah.
By the way, I think similar for people who say maybe 100, 200, 300 years everything was better. If we could put someone on a real time travel back only 150 years and come 1 week after he or she lives there and ask, do you want to come back to the 21st century?
Yeah,
well, now we have many, with the current war in the Ukraine, we have some things that may develop unpredictable. That is not nice. So I really think the 80s, 90s have been nicer, like it is right now. But I don't want to go 100 or 200 years back.
Yeah, no, there's been a few interesting TV shows that have done that, living in the in 1900s and things. And I remember some family was put back there, and they were allowed to buy one thing, I think, something from the modern times, and a lot of people, I just want shampoo. They wanted modern detergents was the thing they lusted after, which is kind of weird.
I have forgotten which channel it was. There was a recent video, not even a week. Dark Matter 2525, or this channel who did make atheist videos long, and he has a video. He brought out a video, I think 1 week ago, where he talked about the life expectancy you had 100 years ago, and also how many people died as children. And he showed that we had, for several thousand years, we had a minimal incline in population, and it went up with the invention of modern medicine. And all the people who are against modern medicine should think about this, and who say the big pharma is only lying to us and all this, they should think about this.
Anyway, that's probably a topic for another day.
Yeah.
All right,
okay,
Martin.
so I wish you a nice afternoon, and I will probably now go outside in the pool, which is directly in front of our room. I can give you a short view on this by fetching the camera.
Jealousy. Look at that. You're right in front of the pool. Yeah, wow.
Yeah, it's a shared pool for, I think, 8 bungalows or so.
Oh, yeah.
And it's a nice little, I can recommend this area here. It's in Nayang, Phuket Nayang, and it's much nicer than the other larger, more populated areas, Nayang, and a little bit less expensive, but nice, not too little. I think this hotel has about 50 or maybe only 32 or so of these little bungalows here. And the one in which I was 3 weeks ago is similar to this, and much plants around and very green. And we were in between. We were at Bang Tao Beach, which is also nice. But compared to the hotel we were there were many concrete flooring, and it got very hot on the day. And also, what especially my wife hated so much, in the morning at 6:30, people come put their towel on a beach chair and reserve it for them for all the day. And they come at 11 o'clock or so. And the hotel writes, they have a policy, they don't allow this, but they do not enforce this. And as they have a little they have more rooms than chairs around the pools, and so if you don't do it, you have no chance to get it. I can somehow understand people who do it, but I hate it.
Yep, you just throw that towel off and you're sitting on that chair, and they walk past and they go, I don't know what you're talking about. So I thought you had to move hotels because you trash the hotel room in every place, but it's not that. Okay.
No. Okay.
The wild parties. Yeah. No, I've enjoyed my time in Phuket. I enjoyed my stay in Phuket. So yeah.
Where did you stay?
Oh, so many years ago now. I do remember we went for a trip to the PP Islands. I think we might have been staying with some expensive resort there, and the resort was organising the trip. And then I went to the local people. Their trip to the PP Islands was about 1/10 of the price. So
okay.
we're sharing the boat with people with chickens and stuff. So that was good. I got a trip with the locals. So yeah.
But on Phuket, was it which? Do you remember which side of the coast was it? East, west?
No.
Okay.
I could get my wife on the stream. She'd probably remember. Yeah. The what's that? Some French company that's. Yeah. Anyway, yeah. This is when I was a young man. I think I was 25 or something. No, it must have been 35. That's right. Yeah.
Okay.
Anyway, yeah. Cool. All right. Yeah. Well.
Okay, the weather in Australia now is hot.
Yeah.
Hot
Look, I mean,
temperatures, or?
it's heading into autumn. So, but yeah, it's fairly warm up in the studio at the moment. So, yeah.
Hmm. And probably in the time we usually make our holidays, that is usually February or November. It are probably the hot times in Australia.
So there, if people can zoom in on that, they'll be able to dox me, because there's
Okay.
up there is my degree.
Okay. Okay. Then maybe one time we come back to Australia. I put this in a mail. We were once there, but only on the Uluru and in Sydney.
Yep.
And then we changed to New Zealand and had about 10 days on the north and 10 days on the south island, and until we returned. And maybe my wife always says we should go it is the east coast from Sydney up to Brisbane. Is it Brisbane?
Yeah. Well, yeah. I mean,
And Cairns.
yeah, you should got to do the Great Barrier Reef before climate change destroys the entire reef. So, yeah, do that.
But can you? Aren't there sharks around the Great Barrier Reef? No. You can swim there without risking your life.
Absolutely, yeah. I mean, you might see a reef shark, and that'll be exciting because it's a shark, but it's only probably 50 centimeters long or something like that. So.
We had a very nice, but it is now 25 years ago, holiday on the Maldives, and we did some snorkeling, and it was very, very nice.
Yeah, very
especially
similar
if you swim snorkeling out over the reef, it is a little bit the feeling like you take off with an airplane. It's the ground goes down, but if with a little bit of imagination, you can think you're going up now.
Yeah. Go tilt the nose.
Okay, then have a nice afternoon.
Yeah,
and
right.
Maybe
thanks, Martin.
If there is an opportunity, we meet again.
Yeah, indeed. Yep. All right. Cheers.
Okay, so goodbye to everybody who viewed this. And maybe I make a stream tomorrow where I explain once more a little bit about my best, beautiful Earth shape tester.
Yeah, and I might get around to doing the test in Australia for you. Yeah.
Okay. Possibly. Okay. Thanks. Right. Goodbye.
All right. See you, Martin. Bye.